Happy Sunday. Good afternoon, good morning, good day to you all. This is PFG Live. And the reason I came in laughing is Kevin Blodgett put a comment in the chat. He said, "Greetings, fellow mechanically inclined people." Anyway, welcome everybody. It's a cool, meaning like really cool Sunday. It's very nice here in New Hampshire. Current temperature is 75 degrees. 75 degrees in southern New Hampshire. We're interested to hear your weather reports briefly as we get underway. It was so nice that I had both shop doors open. And I was cleaning and sweeping and stuff, and the warm air was wafting in. It was glorious. It wasn't snowing, is what I'm trying to say. So how is everybody? I'll say good morning to, I missed a few people in there. Metrological Apparatus was number 1 this morning. Congratulations. Silo's Garage, nice to see you. Who else is here? Of course, Kevin Blodgett is here. And, yeah, welcome, guys. So, as promised, we have a special show today in that we're going to be talking about a piece of equipment that 2 out of the 3 of us that are going to be on your screen have, and I'm the one that doesn't. So it'll be a lot of fun. Mr. Simpson, welcome aboard. 70 degrees and intermittent showers near Detroit. I've been told my showers are a little intermittent, too, by my wife. Welcome aboard. Let's see how the technical stuff looks. It looks like 7 live viewers at the moment. That will ramp up. And everything looks healthy. So I've been working on a project that we're going to talk a little bit about today. I hope, if you've been following on Instagram, I've been making these pins out of S7 tool steel. See if I can show you that. And this pin is the basis for a device. Kevin Blodgett reports 60 degrees, partly cloudy in Oregon. Partly cloudy in Oregon. That's shocking. Dat2T, the 2T, I don't know how to pronounce it, is 18 degrees Celsius or centigrade, depending on which side of the street you're on, and cloudy in southwest Germany. Welcome aboard, sir. And CJ Stevens says good afternoon, which is technically correct. So these pins, which I'm seeking some advice and counsel on from the present company, are actually going to turn into something that looks like that, which is the firing pin for a Benelli Olympic standard pistol. And the reason we're making them is that, as you may or may not know, I was on the MIT pistol team, and which was some serious business, and they've been cracking them, and we don't know why. So we're trying to solve that problem. Mr. C.J. Stevens reports 70 degrees and partly cloudy in East Tennessee. As far east as you can get, I bet. So first time with S7 tool steel, did the proper heat treating, and they came out great. So the next step is all grinding. And I'm a little nervous, but I have enough stock, and we'll see where that goes. So let's get underway. I'm going to introduce you to our guests today and have them tell you a little bit about where they're at, and then we'll get going. So please welcome Adam Demuth and Aaron Walla. So let's see, Aaron, why don't you lead it off? Tell your story and why you're here today.
Well, I'm a tool maker. I'm a mold maker. I'm on the show today, I think, because I just bought a new used Parker Majestic surface grinder. And I was on the show before talking about what I was looking for in a grinder. And I really found the dream setup.
Awesome.
Found it right after I finished finished my shop enough to start putting stuff in it.
And tell everybody where you are.
I'm in Minneapolis, Minnesota.
Outstanding. And Adam Demuth, no stranger to these video pixels. Tell everybody about yourself and why you are connected to this conversation.
I'm a die maker in Eastern Ohio, and I own 2 Parkers, and I don't know, I get into some unusual stuff with them, and I've, from a career standpoint, used a lot of different Parkers, and it's just, I don't know if it's the best grinder. It's the one I know the most, though, and so it's what I go to when I need a grinding solution.
And you're in Ohio.
Mm-hmm.
So now Parker is an American company, and correct me if I'm wrong, that machine is built in the US of A down the street, right?
Pittsburgh, just north of Pittsburgh, actually. Used to be made in Detroit, and the owner, Parker Majestic, was kind of looking to get out of the game and retire, and he went to his biggest purchaser of machines, which was Penn United Technologies, and they own many dozens, like if not 100 of various types of Parkers, and asked them if they'd be interested in purchasing the company. Because at that time, some of the first CNC Parkers to ever get built weren't actually built by Parker. They were built by Penn United Technologies. They'd done their own retrofits way back in the 80s. So they were way ahead of the curve, even than the manufacturer, when it came to CNC integration. And so they agreed to purchase it, and some of the machine builders moved from Detroit to Pittsburgh, and that's now where the companies ran from.
Pretty cool. So it's a little closer to my neck of the woods in Pennsylvania. And so, Aaron, tell the story of how you ended up finding this thing.
Okay, well, for starters, I have a Herrig 612, and it's a good and accurate grinder, but it's not exactly everything that I wanted. And so I've been on the hunt. At work, I use Mitsui's historically, although right now I'm at a place where we have Chevaliers. And I fell in love with the Mitsui grinders and was kind of looking for a Mitsui manual. But I knew that I really wanted to get into a CNC grinder, but I never really saw them for sale. So I kept digging, kept looking, holding out for what I wanted, which was a very good condition, sort of CNC capable grinder, although I've been looking at manuals too. And I found this one in a local auction. It was owned by a professional instrument company. And so, of course, I called Cyrus and I was like, hey, what do you know about this grinder? And he had actually used it during his internship there. And
cool.
I went to Pico and had a look at it, and it looked like it was in really great shape, although there's no power to it, so I couldn't test anything. But in the end, I was able to snatch it up in the auction. It didn't draw nearly as much attention as I thought it would.
So that machine has a what's the proper name of that control?
So it's an Allen Bradley control. It was retrofitted. The surface grinder was built in 1966, and in 2006, Pico sent that grinder back to have it retrofitted. So they put the Allen Bradley control on it. It's got kind of the basic canned cycles that you'd come to expect. I like the way the control works better than, say, like the Okamoto, at least so far from reading the manual, right? I haven't run the grinder yet. But
so full disclosure, I have the Okamoto, right? I have the
I meant the Okamoto automatic.
Oh, okay. So not the CNC.
No, this is a little bit, it's a little bit more like a tricked out automatic than a full CNC surface grinder.
But actually, you know who has essentially that control on the Okamoto is Grimsmo. He bought the Okamoto with not the Fanuc control, with their, you know, is it an Omron controller?
Pretty sure.
Yeah, something like that. But that's in the same class as what you're talking about. So that's pretty cool.
Yeah, I
And
did look at that.
my Okamoto, if you run it in what they call semi-automatic mode, it behaves like that. So it basically, if you're used to that kind of grinder, you can walk up to the Okamoto and run it, and everything feels comfortable. It's only when you get into the other modes that it starts getting kind of crazy. So you just got it. It just came in this week. Have you fired it up?
I haven't. I just had my electrician over, and we're deciding on how to get the thing wired up. And I think what we're going to go with is I'm just going to get the smallest phase perfect phase converter, and I'm going to run just that machine off of it. Although it's capable of running two manual or semi-automatic grinders. I don't know if it would run, a grinder like what Adam has or what you have. I don't know what kind of power draw those have, but basically just something small that lets me get started. Eventually, I plan on getting more three-phase equipment, and I had planned on getting a larger outdoor unit to power everything, but it'll be a while before I can get that thing up. So I didn't want to wait that long to have the grinder up. I've got work I can be doing on it now.
So Adam, what's your three-phase solution?
So I am taking my 240 single phase, doubling it up to 480. Luckily, my 240 comes in a little hot, so the not quite double actually drops it right to about perfectly 480, and then it goes into a 480 phase perfect and creates three phase.
So I remember this now. It's all coming back to me. You are actually running 480 three-phase in your shop.
Yeah, I also have 243 phase.
Okay.
I saw value in having some redundancy, not everything in my shop relying on one phase converter.
Yep.
Because those do go down.
Yep.
And so that's just kind of the path I took.
And I'm running off of in my whole shop, there are two phase perfect 10 horsepower converters, one on each far end. One runs the Sharp VMC and one runs the Okamoto. One I bought brand new, and the other one I bought used for a song and for doing a little bit of electrical work for a guy. But they're serial numbers away. So the phase perfect that you're looking at, Aaron, is that a brand new unit in the white box?
Yeah, I mean that's all I've looked at so far. Looks like it's about $1,000. No, I'm open to suggestions.
That's
what
what
Adam just said about having some redundancy built in. I think that's a great idea.
What power is that rated for?
The grinder?
No, the phase perfect that you're looking at.
Oh, it needs 30 amps in and it puts out like 19.
So that's, help me on horsepower here, because mine.
Oh, I think it's a 5 horsepower, maybe it's a 3 horsepower.
That's an interesting size. I think the 10 horse was the smallest that they made back then. Okay. But I could. So my phase perfect experience has been immaculate, like turn on work, and it's been that for 15 years. What converter are you running, Adam?
2 phase perfects.
So awesome.
Now, what's interesting is talking to a lot of my electrical engineering friends, they associate them with static phase converters. I said, well, they're digital, and I can't necessarily, as a meathead, explain the difference, but I do know there is a difference. But yeah, they all tried to push me down the rotary path for my application, but everything I read about phase perfects and using them in machine shops, it seemed like it was the way to go. Just none of my electrical engineer friends had any experience with them.
Well, if I could push up my electrical engineering glasses on my nose here and weigh in, I looked at the schematic for that converter, and basically the digital part of it is that they're synthesizing the third phase. I may be getting this wrong, but the third leg is being synthesized, and it's well done. I mean, I looked at the schematics. It's been too long, actually. We should probably take another look at it. But they're doing a good job. I had one problem very early on with the Phase Perfect in that it was kicking out when I was going from high RPM and basically stopping the spindle from high RPM. And what happened was the Phase Perfect was interpreting some of the back EMF as spikes, as noise, as bad things happening, and it was shutting down. And that happened a couple of times, and I called those guys up, and they were very helpful. And they said, yeah, we have a sense circuit for that sort of stuff, and if you go to this dip switch on the board, dip switch number 3, and just turn it off, that whole thing will go away. And it did, and that was 15 years ago. So I think it's a great choice, and I'm interested to see what this smaller Phase Perfect looks like. So all of that to say, I think it's a great choice.
I pulled up the information, and the 5 horsepower one is 30 amps and 19 out. The 3 horsepower, it only has 20 amps in, and I've already wired that spot with a 20 amp breaker, so it might be the perfect spot to put this. Otherwise, I've got to run another 30 amp, some more number 10 wire to that position. I didn't do the best job of planning out my electrical situation. I kind of just stuck 240 outlets all over the place, thinking that I'd be covered, but in reality, it was just a waste of wire because it's not really where I need it, and I need to, get a phase converter in line for those spots. So I'm just going to end up running conduit, like I can see on Adam's wall.
And yeah, we also have conduit. All of the shop wiring is conduit.
Yeah, I think that's a more sensible way, but I wanted it to be clean and look clean. Inspired by Adam, actually. I love how clean his shop looks.
Thanks.
So, do you have a electrician with a sense of humor?
Well, I would say no.
Is he a little grumpy?
My requests aren't always the simplest, so
yeah,
there could be some grumpiness.
So,
but the guy that was out here today, he's really.
I just had my electrician in last week after waiting for a while. I know nobody has that experience, having to wait a while, but he's pretty cool dude, and he put in the charger circuit for the electric truck, and we ran. It was like its own 100 amp home run back to the main panel, and we did all conduit, all number 3 wire. So to me, it was a big deal. But once he started, it was like a blur, and he got it done. So that was pretty cool. Kevin asks a question: Is there any issue with the grinder using 110 volt accessories and needing power separate from the 3-phase?
On the back of my CNC Parker are M-code activated 110 volt plugs.
That's awesome.
So I can turn on a spin fixture at the start of a cycle. Because sometimes on CNC grinders, you forget to turn on the spin fixture.
No.
And so just to be able to have the machine kick it on when it needs. And you could also use it for spin dressers. If you have a 110 volt dust extractor, it can fire that as well.
That's pretty cool. I have that exact problem right now, where I have
to create 3-phase, give it to the machine, which creates single phase.
On the Okamoto is even worse. I have 220. I make 220 3-phase. That goes into a transformer to make 200 3-phase. That goes into the Okamoto, which, if you look really carefully, has a 115 volt transformer to feed the magnetic chuck circuit, which then makes DC to drive the magnetic chuck. So somebody's making a lot of money. But I also want to get a relay set up, and I know it's totally doable. I just have to set a couple hours aside so that the fume extractor, the mist extractor, turns on anytime the coolant pump is on. If I could do that, that will be a major quality of life improvement for me. A couple of people checked in here. I just want to acknowledge them. Metrological Apparatus, who, by the way, was number 1 in the chat today, but was late with their weather report, said it is standard temperature of 20 degrees Celsius in France. Thank you. And K-Bonk just woke up and is drinking a Red Bull, and he reports it's 75 degrees and mostly sunny in Philadelphia. So, Adam, you gave us the history of this machine. It's pretty cool. I love the fact that it's American made. I was not familiar with it when I started my journey. But is there anything fundamentally different any approaches that they take that are fundamentally different in the grinder?
Compared to a lot of like tool room class surface grinders, I think they're very generous with the amount of head travel elevation wise. So you can get really tall work pieces on the chuck under the wheel. And a lot of my tool room work has overlapped with machine building. So yeah, we're making punches and die components, but we're also making like a base for a robot to sit on. And so we needed to be able to build somewhat precise, larger stuff. And I felt like that was always a lot easier on this style machine than some other tool room machines. So that's what always drew me to them, is it's just a lot of headroom and kind of a versatile layout.
That appeals to me too, because I often have to, grind long pins or long parts that have angles on them, and as soon as you start stacking, sign chucks and things, you lose a lot of Z room right away. So that's why when I was searching for a grinder, I was limiting my search to Parker Majestic Mitsui. Mitsui has a 612 grinder that's got an extended Z height too, which is pretty nice. I've used every bit of it in the past, and it's nice to have when you need it.
So I noticed on both of your machines, well, actually more on Adam's machine, that there's no real enclosure going on there. Are you ever... And he's wrong. There is an enclosure. Are you running coolant on yours?
The CNC one, yeah.
Okay.
Some of the materials I grind on it need coolant, so
okay.
The manual one, it's just dust extraction.
And what about you, Aaron?
I use it intermittently. It depends on what I'm doing. I like to have it. So I do plan to set it up on my manual grinder once I get it moved over here. But, a lot of times you lose a lot of time when you're using coolant because you have to do a lot more cleanup between parts. And so if you kind of know how to manage the heat, you can avoid using it for a lot of things. Now, with some of the harder tool steels, it can be problematic, but a lot of times it just depends on what you're doing. If you rough stuff and then finish it in a separate cycle, you can kind of get rid of most of your heat problems and grind dry all the time.
And I, of course, am in the totally opposite camp. It's like if I could be grinding in a swimming pool, I'd prefer that.
Yeah.
But it's a different animal. And yeah, you need a whole separate set of infrastructure to deal with coolant. When I started with the 612, the mist, the Noga mist, Noga, is that what it's called? Mini Cool. The Noga Mini Cool mist coolant schnozzle thing, spitter, was the thing, and that's actually pretty useful, I guess, in some situations. Is that I see Adam saying, nah, not so much.
So all the downsides of coolant without the total solution. Like it's still the same amount of mess, same amount of time between parts cleaning the chuck, but it's not as effective as coolant. That was always kind of my takeaway. But I know a lot of people use cold air guns, but I think that creates the opposite problem. You get your part too cold.
Too cold, and it's so messy and noisy.
Oh, yeah. Yeah.
And it uses a lot of air.
Yeah, usually the shops where you see that, they don't have the air compressor in the building and don't notice how much it's running.
Yeah, and they don't pay for the electric.
Yeah.
Yeah. No, I've never tried one.
One issue that I run into a lot with coolant is that I never feel like I get it exactly where I want it when I'm grinding. You know, you can get the part wet, you can, you know, but it's really hard to get it so that your coolant's right at the contact point between the wheel and the part. And what I want to do with this one is I want to run multiple coolant lines. I want to have your standard, you know, wheel coolant that everybody's got. But I want to set up a separate, smaller line that I can connect with just a Noga base, so I can position it on the magnet and put the coolant exactly where I want. So an example would be like sometimes with pin grinding, rotary grinding, you know, you're not getting it where you want with the one connected to the wheel. So if I could just position it where it stays on, I think that would have a great benefit.
It's almost as if there's a market for one that kind of focuses the coolant stream at a point, maybe with some vector from the side, you know, maybe there's one, if you go to noz.gg, noz.gg, you might find one. That's the commercial. Yeah, and actually, to be honest, the Noz, I designed it to be focused on a point, right? But the reality is it hits the side of the wheel, which is desirable, and it hits the bottom where the part is, and I find that it does multiple good things that I didn't expect. End of commercial.
Well, I'll have to try one. But
Well,
I have a bunch of tips in my box because there doesn't seem to be a one solution for everything. So I just change them out as needed.
All right. Inbound. It's coming. Do you have a Noz, Adam?
I have the prototypes.
That's right. You were my first guinea pig. I mean, tester. All right, we'll get you a Noz. Pretty cool, so to speak. So, what was the most surprising thing about the Parker Majestic grinder, and then secondarily of its controller? And I don't even know if you've had a chance to run it, Aaron. Am I correct?
Yeah, I haven't had a chance to run it. I've poured over the manual. I'll say one thing that caught me by surprise is when I was trying to lift the spindle off the 4x4 block that it was secured to. It felt like the spindle wasn't moving at all, and I'm cranking the handle. And then I looked down to it, and I realized that the Z feed wheel is 10 thousandths per revolution.
Wow.
And I didn't know that. And that explains why there's power feed on the Z axis on those machines. But I think that's pretty cool. I'm impressed by how much meat there is to it. There's really a lot of cast iron. It's a heavy machine. If you put it next to my Herrig, it would definitely look like it's, you know, bigger, buffer brother. And so I'm really looking forward to running it. But Adam's definitely got the more hands-on experience with it.
So what's the most surprising thing about that grinder compared to other grinders on the market? Besides, you talked about the Z height. What else distinguishes the Parker Majestic?
I think the CNC conversational elements are very much so geared towards people that have ran grinders manually. Kind of speaks the lingo in our world, so to speak. And I I just felt like I wasn't kind of trying to search for their understanding or what they were trying to say with the way they describe things. It all made sense to me because um, there was just a lot of institutional operation knowledge of grinding die components, and so when they mapped out how they want these CAN cycles to work, they went to the right people in their company and planned things accordingly. And then the other nice thing is there's just a lot of versatility. They didn't just do it the way they thought it should be done. They gave everybody who runs grinders options. I mean, there's half a dozen different dressing cycles. If you're doing super abrasives, you can do it several different ways, and so I thought that was pretty well laid out.
I'll tell you one thing you are not fighting that I have to fight is the translation.
That was my other concern. I really didn't want a Fanuc ran machine, and that kind of wipes out both Okamoto and Amada.
I spent a lot of time, an unfortunate amount of time, with the "what do you really mean?" question. Like, I think I showed it recently, dressing the wheel. You give it parameters, and then there's a button that says transduct. It's like, okay, I think you mean transduce, but you really mean translate to G code. And it's just, of course, once you slog through it, oh yeah, push that button. But when you're trying to like literally communicate with the control on that machine, it's like, what are they trying to say? So I'm a little jealous about the fact that American is used in the control. Not that I'm adverse to other things, but
by ruling out Fanuc, I was left with either going with a Jung with their Siemens control, but that was a big jump in price, or you get into the world of PC-based controls, and that wasn't an avenue I was willing to go down. I've just never seen longevity in PC-based controls. Usually they have like an XP machine on life support just to keep some obscure piece of equipment running. Yeah. And I didn't want to deal with that. So,
see, I'm curious about that, Adam, because when I was at Pico, I saw that they've just got a fleet of Mitsui 8x18 grinders, CNC grinders. And I haven't run one before, but they look like super capable machines. I don't know how they, perform. I don't know. Can you explain to me more about the issues with PC-based systems? Because in the future, I do plan on getting a new CNC grinder, but I think it'll be between a Parker and a Mitsui.
Usually my trepidation with PC-based control systems comes from older metrology companies, where you have a piece of equipment with zero wear, but it's been rendered obsolete by the computer that's attached to it. And like Fanuc, for all that's wrong with it, you can keep a 30-year-old Fanuc control running no issues, and parts are next day available. And same with Siemens or Heidenhain. Any of the big from a person who doesn't want to have to kind of tinker around with computer components, just wants his machines to run, I find value in a industrial control. But people I talk to that have a lot of computer background, they don't agree with that. They say, oh, no, you can always make computer run, you could do this and that. And it's like, yeah, I don't want to do that personally. I just want to make a phone call and have my machine running again.
Right. I get that, because I don't know. I think that you could probably buy a grinder for a one-man shop and run it for the rest of your life, as long as the control components hold up.
Yeah, and that's kind of my thought here, was this will get me probably to the end of my career. So,
okay. And one thing I could say about the Fanuc control, which you avoided, is that I have the same control on the Sharp. Mm-hmm. It's just bulletproof. Like, it'll be running in 100 years, the thing will be running.
I have a Fanic elsewhere in the shop. I just didn't necessarily want it on the grinder because with grinding, it's a ton of setups. Like I recently did a part, there was 19 individual operations. And, each operation might take them 30 seconds is grind this side, flip, grind this side. And so you're just doing a ton of operations, very, very brief programming. And I wanted the control that allows you to program the fastest. And Siemens has an ability to just really edit a program very quickly, like say a depth of cut or a step over amount. You can instantaneously change it. And it's just a few more keystrokes on a Fanic, but a few more keystrokes over a 19 operation project really starts to bug you. On my mills, it's not a big problem because I might do 1 or 2 setups a day, but when you're doing a ton, it starts to add up.
But on the mills also, you're probably starting in Fusion, right?
Yeah, so I don't actually really do much of anything on the mills because I have the work defined in Fusion, so it already knows I don't have to touch off the work. And basically, I load the file over the FTP server. It knows what file folder to look in, and I just have to hit cycle start. So the Fanic complaints I have aren't really valid there, but they would be on a grinder.
Okay. And do you have canned cycles for doing like pin grinding and a spin fixture and that kind of work on your Parker?
You can use some of the plunge grinding cycles, and then you could use some of the contour grinding cycles and just kind of give it like an XY profile and don't do any, or I'm sorry, a YZ profile, and then don't do any X stroke. I do wish there was like a lathe canned cycle where you can tell it, the pin size is this and peel off this much stock, and you kind of how a lathe turns a component shape. But they also sell cylindrical grinders that have those cycles, and so I wonder if like they don't want to make the basic surface grinder with a spin fixture compete against their cylindrical grinders. Maybe it's not that, but
is it something you could do in G code?
You can absolutely do it in G code. You could do it from Fusion with a lathe post, or you can also write your own can cycles with Siemens. That's another powerful possibility is you can define your own can programs. So
that's one thing that I wish I had on my control. I think I'm not able to save any programs or input G code, which is unfortunate, but it's a pretty capable machine. It'll work for me.
You'll probably be able to do 99.5% of everything you're imagining without it. I was talking to Adam before we went live that I can write G code in my control to run and I have to if the table is not oscillating. This is a downside of the Okamoto. If the table is not oscillating, the only way I can get it to do a thing is writing G code. There's no built-in canned cycle for the table not moving, which is sort of a bummer. And in fact, that's, this pin project that I'm doing, I'm going to be back to writing a little bit of G code. It's not a huge deal. It's going to be, come down to here, go here, do that a couple of times, and that's it. So it's not a lot of G code, but it would be super cool if it was built in to the control. And are you sure that, so there's no way to save anything on that control? Is that?
That's what I read.
Yeah.
I haven't run it yet, so I'm not 100% sure. Now, Pico was using it for roto grinding, and I got some work instructions from them on how to set it up that way. They basically just would use a table stop and trick the machine by, setting their right and left table stop in the program at the same time. And then they, I think, disconnect the belt for the wheel, or a belt for the reciprocation.
Yeah.
So I'll have to experiment with that.
Wow, that's a good experiment. I'm gonna have to try that.
Yeah.
I don't think it'll let me get away with it, but we'll see. Because if it did let me get away with it, I think I'd be a very happy camper.
And I
Like
could
you said,
always use it manually there too. I wouldn't want to do any reciprocating grinding manually because there's a clutch on the wheel or on the handle. But if I'm just manipulating Z and Y, that'd be easy enough.
so I want to selfishly talk a little bit about pin grinding because I haven't done a lot of it, and I want to get these things done. So my plan is to set up my spin jig parallel to the spindle. I was going to say the Z-axis, but then I was going to get pushback from you Parker Majestic guys now. But parallel to the spindle, and then again just have it come in. Now one of the questions I have is I've got a I don't know 10-to-1 ratio pin hanging out there, and my assumption is that my grinding will be a low enough pressure that I'm not going to really get any appreciable taper. So
I think you'll get some chatter.
Yeah, this is what I want. I need to hear this.
Yeah, you'll get chatter, but also the weird thing is the amount of heat that the hip will hold. It doesn't have anywhere to dissipate other than down the shank. And so as you're grinding, the tip can really hold on to heat and do weird things to you. So you have things like spring-loaded steady rest that can push up under it, or like a teeter-totter or seesaw arrangement that you can have a weight you slide and it applies weight. But that might be a good candidate for like a basic homemade centerless setup.
So Robin had done a homemade centerless setup a while back. So that's a possibility. Of course, I want to make sure that the cylinder, which is already concentric with the head. I shouldn't say that. The concentricity is not a big deal because it's all going to get machined. The head's going to get machined later. So,
are there centers in it?
Say again?
Are there centers in it, or are you doing it on your Suburban?
So there's no centers in it. I could redo this and put a point on the end, which is a reverse center. And I have my little Harrig electric spin that has those. I could flip those guys around and pick up that point. On this side, I have nothing. So I was thinking I could make a little cup with a center on it to hold it. That's another approach. And then I'd be holding it between centers and do it a different way.
Do it one operation. The head and the shank. Are you grinding the heads too?
No, the head's a whole different problem. So the answer is yes, I'm going to grind the head, but it's not rotary ground. When the shank is all done, and there's actually a two different diameters that are going to be on the shank. There's going to be a larger diameter and then a smaller diameter. Kevin Blodgett says, does the centerless solve the heat issues?
In a lot of ways, yes, because it's kind of up against like a little shelf, and it gives a opportunity for the coolant to kind of stay around the part longer. So anytime your part's up in air and like you don't have the mass of the work holding kind of keeping the coolant concentrated around it, you see a little bit more heat issue. And so a pin just hanging out in space, the coolant just like flows around it almost. And I feel like if you have some body around it for some more splashing, it slows down the flow and keeps the coolant on the part longer.
I kind of want to hear more about the centerless, hack job that you're, and I say that lovingly, improvisation. The centerless improvisation, how to do that. Because what I'm hearing from you is almost like a little angle to hold the pin. Robin, I think he used a couple of bearings. I don't quite remember How would you set this up?
From what I remember from Robin's video, he just had like a 1, 2, 3 block size piece of metal, and he cut like a 60-degree notch in it. And I think he had a piece of spring steel, maybe,
Yeah,
holding it
yeah.
in. But then you need some way to drive it rotationally that's not going to influence it much. So I think he had like a hex head bolt he put into a thread or something,
That's
and
exactly
used a
right.
pistol drill to drive it. But I don't know what your options there would be. But sometimes with parts, when you're prepping them for heat treat and grind, what we used to do a lot when we made pins is we'd double end them. So you'd have 2 parts joined at the head, maybe like a little notch. And so when you're done, you could slice them on an abrasive cutoff wheel and just kind of clean the top up. But you grab onto the part you're not grinding, like, say it's just like a straight shank. You stick that in your collet, and then you can grind the head and the pin of the other side of the 2-part assembly continuously.
Yep, that would have been brilliant. I just left myself enough, which I thought was enough to grab in a collet.
Yeah, that's not a lot to grab onto, but I think, I mean, there's a lot of good options, or maybe not great options, but I think a little steady rest is something you could build in a very short amount of time, and it's something that'll come in handy. I've posted some of the one that I made on Instagram, but it's just a little simple thing that's got like almost like a pen spring holding a QB pin in a block, and it just has the tiniest bit of give.
Okay. And then you would how would you choose the amount of spring tension? Just measure the pin.
If it's pushing up, you're getting too much tension.
Yeah.
Like if you're getting taper.
So set it by taper, basically. Okay.
What I would do is I would set it up, and I would put my indicator on the top of the pin, and I would get it to where it just barely pushed up a little bit, and that would be my starting point. So, push up a tenth or less, and then start there. And my little box of I've got springs that have been cut to all different lengths for different amounts of pressure, and I've got the heads of the pins. I've got flat ones, I've got plastic tipped ones, and I've got some where I've got a little V in them. But I think, the plastic tip ones where you just use like an end mill container to cover it, that seems to be the most useful. I don't know, the one I use the most.
I missed a word there. A what container?
Like an end mill container, the tubes that they come in.
Yes.
You just cut the end off the tube, and you put that over the pin, so you don't have metal on metal, and it just slides a little better.
Maybe this is an application for a 3D printed widget, and use the plastic of the 3D printed widget.
There you go.
I'm seeing it. I see the light. Okay. May have to go make something. Well, I'll probably do it wrong first, right? I'll set it up and let it chatter at me, and then we'll fix it.
Sometimes you get away with it, so
I wouldn't mind getting away with it. Plus, I do have wheel speed control, so if I can tune it in and maybe change the wheel speed to make to calm it down, is that a reasonable approach? Maybe.
I don't know. I've always had the equipment I needed, like a steady rest or some kind of other method of doing it. So like if it looked sketchy, I just wouldn't go down that path.
Yeah.
But nothing bad's going to happen. You'll just kind of you might experience some chatter or burning, and but you live, you learn.
So we have some questions.
Every time you change your speed, you got to redress your wheel, and so you'll probably spend a little back and forth time doing that.
So I see the rabbit hole you just pointed at, and I don't want to go down it right now because it's a day's worth of discussion. Theoretically, you shouldn't have to redress the wheel if you just merely change the speed. but I
What do
recognize
you think,
that's
Adam?
what's that?
I'm curious what Adam thinks.
I'm big fan of wheels need to be dressed to the speed they're running.
Okay.
Because especially with like a heavier mass wheel, like a super abrasive, as if the speed goes up, the amount of eccentricity is going to increase potentially. And so I've always redressed if I change speed. But with the CNC, it's as simple as hitting a button, so it's
Right.
not a big deal.
So all of that, the 800-pound gorilla in the room is that exists because of some mass imbalance. You have to have an imbalance for that to be true, right?
Yes, and you always will have an imbalance.
There is always an imbalance.
Just a factor of how much.
Right. Okay. We're in violent agreement. K-Bonk says, is there a preferred feed direction from head to tip versus tip to head? ?
Yeah, I think that a lot of that depends on if you need to have a really sharp corner or not. So what I'll usually do is I'll feed in on the head and then feed off the part. Now, I suppose you can go the other way, but the problem is then you're getting your wear on the front edge of the wheel. And so when you come up to that corner, you're going to have more of a radius. But it probably doesn't matter in this situation.
Actually, we're going to have a defined radius, so I'm going to be dressing the radius onto the wheel.
Another thing you could try, Spencer, is to dress a little step and to make your wheel narrower. Like maybe just have 100 thou past that radius, so the amount of wheel engaging with the parts reduced, and that'll help with your deflection and heat.
I like that.
Yeah, that's very good.
That's an excellent idea. I have a lot of dressing options on that machine also, and I'm sure I can figure out a way to tell it to make that shape on the wheel. I don't think that's a problem.
So a lot of times I don't even mess with that. I'll just use a piece of Norbide and kind of touch the wheel and knock a few tenths off, and then when I'm done, it dresses away. But
that would be the expedient way, but it's not nearly nerdy enough.
What kind of radius do you need?
I think it's going to be a 30,000ths type, maybe even less. The answer is I don't know, but even less. It may be a 10,000th radius. So
if it's 10,000ths, that radius will form itself while you're grinding.
Yeah. Greenwood says, I like head to tip. I'm not judging. Helps control diameter as your wheel breaks down. Okay. K-Bonk says, with coolant flow, ? In 3D Gizmo? Ooh. So I think what he's implying is that some coolant flow trickery can be done if I 3D print a little support widget.
Make a little gutter that goes under it.
Or I can have little mini nozzles that point at it, right? That come out of the 3D printed thing. We'll figure something out.
The application where, I want to have a separate coolant supply that I can just position wherever I want.
Yeah.
Because I just set it up so that it kept the pin cool, and instead of having it, where you can never quite get it just right when you're setting up to grind a pin. You usually have it one side of the wheel or the other. I feel like you don't get it where you need.
Indiana John, in a state of shock, says, I've never heard of redressing 4 different speeds. Stick around, Indiana John. This is where you learn these things, okay? I learned it too today, so that's good. Yeah, that's fascinating. Well, I will report back to the group how I do here. If I could make 10 of these pins, I'm going to have a very happy team that's going to be all set for a while.
This is what you need for those.
Ooh.
This is the latest edition by Shop.
That looks like money. That looks pretty cool. So is that a for the rotary for the spin jig? Where does that go?
It goes on. It'll go on my new bald spinner. So you take the V block off and you put the chuck on,
Yep.
and you indicate it in, and it repeats really well. I had planned on getting a smaller one, but the only issue is you have to have like a full 8-inch wheel to
reach down there.
Yeah.
Hey,
the smaller ones are like an inch smaller in diameter.
I live not too super far from Herman Schmidt, and I know they changed hands recently. Apparently, it appears to have gone very well as far as keeping the culture.
Yeah.
But wouldn't that be cool to go down there and do a little thing with them and learn something from those guys? So if anybody knows anybody down at Herman Schmidt, I'm not adverse to just picking up the phone, but let me know. That'd be kind of cool.
I'd love to meet the kids that I'm putting through college.
That hits a little too close to home. Robert Simpson asks, is there a short explanation for dressing for different speeds? Not a grinder hand, so no idea. Let me take a shot at it, guys, and then you could yell at me. A grinding wheel needs to be balanced. If you have a grinding wheel where its center of mass does not correspond with the center of rotation, then it's going to act like a pendulum, and as it goes around, it's going to yank on the spindle, which is going to bend like a piece of pasta or rubber. If Robin says rubber, I say pasta, and you're going to get wheel hop. So you come in with your dresser and you dress the wheel, and the theory is that the hop from the imbalance is going to be compensated by the dress, which is true until the wheel gets loaded. That's my commentary, not the physics. Until the wheel starts having to do work, and then things get wonky. So if you spin the wheel up, you've dressed it already, right? You got a B200 balancing ring, right? Or you have a hub that has your little 3 weights built in, whatever. But you've balanced the hell out of it. You dress it, and now you go to town. If you change the speed, then the amount that the spindle's bending due to the ever-present imbalance is going to change, and you're no longer going to have a smooth cut without wheel hop. Did I catch that?
Yep.
Yeah.
You may not notice that on like 60 or 46 grit wheels, but like you get into a finer finish grinding, you might not even notice it visually until you stone it, and you'll see kind of straight lines, picket fencing down the part.
There's a guy that just bought a set of stones for me who, without prompting, just did like a unboxing video and then showed people how to use it. And I just watched it. It was really nice. It was wonderful. But I had to start laughing because he goes over to his new mill and he says, there's a ding here and I'm going to use these. And he does the right thing and he goes over and he says, I could feel it. And it just cleaned up, and it cleaned up, and he takes the stone away. And because I'm tuned into it, I immediately see wheel hop on the mill table. And then he wipes it away with his hand. But it's like, no, that was still hopping right along. Yeah, you're saying we don't see it on some of the rougher grit wheels. Kevin Blodgett says, this is a fantastic discussion. Thank you, Kevin. We got that. Practical Renaissance says, I would love to see us tour of them. So would I. I think we're going to have to make this happen. How much benefit do you get from dynamically balancing wheels? So that's a super good question. When and I'll take a shot at this and we'll go around the round table here. Well, no, actually, I'm just going to shoot it over to Adam. Adam, Dynamic balancing versus static balancing. Go.
I like the idea of dynamic balancing. You're not leaving anything to chance. Like, say the spindle has an effect on the balance of the wheel, or as you're using the wheel, maybe the balance is changing. Some coolant gets in there. So doing it at the machine, I like a lot. But I've also known like the big system in that arena is the Marcos system, and I've known a lot of people who just kind of find them frustrating to use. Like they're effective, but they all seem to kind of curse when talking about them. But I mean, there is another system. I can't remember the name of it, but it fires on cue and actually like chips material out of the wheel.
Really?
Yeah, and that one's pretty cool. And you don't need any balancing rings or anything like that. And so I think that's kind of interesting.
Do not like it. You don't need balancing rings. I do not like it. Do you have any experience, Aaron, with these dynamic balancing systems?
No, I don't. In fact, the only time I balance wheels are, the big ones for the big Okamoto 12 by 24s. I'll balance those, but the wheels that I put on, like tool room grinders, I don't balance at all. I haven't really experienced it as a problem, and when I do, it's a problem that I can usually solve by dressing the sides of the wheel. Now, I can definitely see the application in super abrasives, though.
Yeah, super abrasives, it's more of a need. Like personally, I don't bother with balancing on for what I do, like most of my 7-inch conventional abrasive wheels. But super abrasive, you're going at much higher surface feet or cutting footage, and you're also more mass at the periphery of that wheel, and so any imbalance is going to become much bigger issue at those higher speeds than it would in a sand wheel.
One of the things I like about the idea of dynamic balancing, of course, I don't have a system for doing that, is that it's also going to balance the motor. You have all these other variables that are downstream or upstream from your cutting surface that you have no control over. We all assume that our motors are balanced, and if they're not, and of course they're not, there's going to be something introduced by the motor, and the theory is that dressing it again will take it out, but who knows?
There is an interesting problem when you're doing cylindrical grinding and you have a little bit of wheel imbalance, is that every so often your wheels rotation and your parts rotation become an integer of one another.
Yeah.
And you get a cog pattern.
Yep.
Like, micro-inch cog pattern, but a cog pattern nonetheless. And so the solution is usually just bump your workhead speed a little one way or the other and break the pattern.
I think a lot about these things, mostly because I'm too much of a nerd, but it would be, I know that Haas in some of their lathes has started to like have a mode where it'll move the RPM around. It would be kind of cool for some tools like that, especially if you're trying to get right down to the perfect finish.
I have a question for you, Adam. You said 7-inch wheels. You're not running 8-inch wheels?
No, I run 7. You can order an 8-inch kit with Parker's. It's just a bigger wheel guard, but it's just a standard non-keyed Sopco 200 hub, and I feel like at 8-inch you're getting up into the potential of spinning that without any kind of keyed feature on the hub. So 7-inch works fine for what I do.
Okay.
And I have a mix. I have 8 inches and 7 inches. The diamond wheels are 7s, 7.5s or 7s. I don't remember. And then I did buy some SG5s that are 8. Just cause. K-Bonk is pointing at Clo 42, which is CLAUGH 42, I think. He just built, we texted about this week. He built an RC prop balancer or he used an RC prop balancer to do a wheel balancing. And he also just made his own 3D printed bearing-based balancing stand that looked really nice. Mark Makes has a Micromaster he's got to get back together. Yes, you do. Widgetworks says, I ran a Studer cylindrical grinder with the balancer system that removes bits of the wheel. It worked great, and it was fast and simple. Fascinating. So here's a fun fact, that when the accelerometer senses the motion of the wheel, that the actual imbalance is 90 degrees away. Think about that. That's in a physics textbook somewhere. That's how helicopters work also. Well, super cool. I want to go nerd out. I want to go grind my pins now. Well, congratulations.
Wheel balance and eccentricity. That's one of my concerns with top-mounted dressing. You ever seen like a top-mounted slide dresser? Everything has to be exceptionally good for them to work well. And they do when everything's very good, but when the errors start to build up, maybe you have a little bit of taper in the travel of that, and then maybe your wheel has a little bit of imbalance. And I just find it a little bit harder to get the results you can get with one of those than versus a table mounted dresser.
I've experienced that too.
Because you're dressing out of phase, so whatever amount of eccentricity you have is now on the bottom, but it's not running out at the top.
Right. So with Opti dresses, I use them a lot for dressing form wheels, but I never use it for dressing a wheel flat unless I just have to, because it never seems to be flat to my work. It's always out a little bit.
Well, I don't have experience. I don't have any experience with the top wheel dressers, but I never liked the idea of them because they're so disconnected from the part or from the table.
They sound great.
I just like them from a thermal control perspective. The column on a grinder will change in temperature, throughout my day. But when you come down and dress within an inch or two of your top of your workpiece, you're basically calibrating that temperature shift on your column and ball screw out of the equation. But that's not the case with the top mounted one. The dresser is riding up with the growing column. So I just, there's some serious production advantages on bigger grinders. But for small grinding, it seems like table mounting is the way to go.
Cool. So much to learn. It's amazing. Just today. Say again?
I said, I actually have two little things that I'd like to bring up while we're doing this. I don't know if we're quitting in an hour, but just save some time for that.
Go ahead. Bring them up now. Nominally, we're close to quitting time, but if we go another hour, nobody's going to complain.
All right. So the two things are, I need to pick a chuck for my grinder. And then I also wanted to hear Adam's experience about some of the different hubs that Sopco makes for ID grinding, or for one I need now is something that'll hold a small cup wheel. And I find that my hubs are too big for that. So I didn't see anything on McMaster. So I guess we could start with the hub. What kind of hub do you use for that? Because I don't think the Sopco 200 works for those 4 or 5 inch cup wheels, right?
That's a Sopco 200 on a 3-inch wheel.
Really?
You have to add an aluminum spacer to get it to sit out far enough, but it clears the hub. But yeah, that's as small as I go with this. For my bigger roughing wheels, they make I forget the number, but the flange is bigger by a half an inch. And I like that just because it kind of looks a little stouter, but it covers the wheel number. So you got to kind of right on the wheel what it
I-
is.
I've gotten in the habit of doing that all the time.
Kind of taste the wheel.
Yes. You know what I've been doing? I've been taking a Sharpie, and then you know the dot peen markers.
Mm.
You know, I've been doing like a dot peen marking on the wheel with a Sharpie, and that lasts a long time, and it takes away the mystery. Some people like the mystery. You know,
I always
I'm
write
not.
on them too.
Most of the time, I could look like I know I use pretty standardized wheels, so I know like, oh, that's a 38, and I can tell that's either a 60, no, that's an 80, but I run different bonds, and so that's where I get into trouble. Like I need to know that.
Yeah, I really wish the manufacturers would put it on the outer edge of their label, but that's maybe too much to hope. Did you have another thing, Aaron, that you want to bring up?
Yeah, I have to decide what kind of chuck I'm going to get. And
Oh, so I have had used walkers go through my hands. Right, that was on the. In fact, every chuck I had until the Okamoto was a walker. Also, a Massachusetts-based company. They're down in. They were down in the Worcester, Massachusetts area. And now I've got the Okamoto brand. You know, it's who knows where they source it from, and it's fine. It's not like glorious, but I'd like to hear what Adam has to say.
I was kind of talking with Stefan. What I kind of wish I would have done is bought like three 4-inch chucks, and just had 3 4-inch chucks, and you could turn on zones. Like if you have a U-shaped part, just turn on the center one.
well, that's interesting.
It's a good idea.
You know, it's going to be more expensive than buying one 12-inch chuck. But, you know, as I do this longer, I see some versatility in being able to control individual zones. But on the new CNC grinder, I had it come with a Walker chuck, and it's the new build of Walker. And I don't feel like they're quite as nice as the old ones. Like flipping it on, it's not quite as smooth. But, I mean, the pull construction's still the same spacing, so I feel like it holds every bit as well, so no complaints there.
What if we convince the manufacturers to make a 8x18 or 6x12, whatever your size is, but give you 4 electrical inputs so that you can go and control the zones, but it's still one chuck, right?
Yeah.
You treat it as one. That way, because the grinders aren't going to be set up to hold 4 things easily. But you can get the chuck manufacturers to just say, hey, listen, guys, just put 4 windings in it. And, let me mess around with the current.
That's the other thing, though. I'm not sure about getting an electromagnetic chuck, just because I've seen some problems with them and the controls failing. So I feel like if I were to do that, I'd want to get a new one, not a used one, and it's pretty expensive. Not sure.
Well, I have vast experience with one electromagnetic chuck.
Yeah,
and it's been awesome. Although I can feel the heat.
Yeah,
and it gives one pause to think about the heat.
One thing so a lot in milling, we use these, they're electro-permanent magnets, so the electric just turns it on and off.
Yeah.
And they're low heat as a result when in use, but you can also move the poles around. They have like pole spacer standoffs. And I always thought if they made them small enough, that'd be nice on a tool room grinder. But I think like the smallest I've ever seen is 12x12. But like from a grinding plates perspective, you could just put like 3 poles on it, and then they have these spring-loaded transfer poles that don't distort the plate. They just transfer magnetism up to it, and you put those in like the 3 opposite locations. And I always thought that'd be kind of a neat approach. But sadly, I've never seen one quite set up for surface grinding.
Interesting.
How do you like having that 12-inch chuck versus a longer one versus the 18 that it was made for?
Oh, I like having that a lot, just because it gives me kind of some room out on the end. I can hang like an L-shaped part I see an unfortunate amount of Tetris pieces come through my shop, and
Yeah.
sometimes you want to be able to hang something down and get that extra couple inches, and to drop it down in that dead space between the chuck and the dresser is handy.
Yeah, I always felt like they shortchanged the X travel on grinders. Like the fact that you can only go like an inch or inch and a half off of each side. It'd be nice to have a couple inches either way.
What's really nice is when a grinder comes off the front of the chuck, like another inch. And Parker's generally you can get at least 3/4 of an inch.
Yeah.
So if you have like a real tall pin, you can hang it off the front of the magnet and gain yourself a few more inches.
And I would vote for a magnet the size of a surfboard, but that's just me.
End shape.
What's that?
End shape.
Oh yeah. Well, the shape, I don't know.
And
So
my next machine, I'll probably just put a Roa chuck on it.
Really?
And, yeah, just not deal with the magnet when I'm not using it.
Yeah, that's what they were telling me at Pico. Their work holding solution is Loctite 425.
Yeah. That makes a lot of sense. No magnet, no heat, no nothing.
You guys want to hear about a near crash I had on a grinder?
Let's pull down the cone of silence. It's just us three. Nobody else will hear.
So, I just got a new job, and my grinding experience was kind of my selling point because that's where I spent all my time, is parked in front of a grinder. And so I was going to regrind the chuck on their Okamoto 12x24, and so I moved the stops to both ends and I set about grinding it. And as soon as it went off the far side of the chuck, all of a sudden it just started grinding the back rail. And of course you could hear it not just anywhere in the shop, but probably anywhere in the molding section as well. And I'm like, fuck, how did I crash this thing? Why aren't the stops like keeping it from hitting the back wall? And so I'm like, I got to figure out what's going on here. They're going to think I'm an idiot. And anyway, it turns out that when somebody took the machine apart and put it back together, there's this back rail for the splash guard, and it's formed so that it goes backwards and then up to give clearance. Well, when somebody installed it,
they turned it around.
So it came out this way and came up, and I crashed the side of the wheel right into that thing.
Oh. Well, it wasn't your fault.
Well, it goes to show when you're on a new machine, you have to be extra diligent. I would say that, it's a preventable accident, but I think in the future I'll just make sure to run it manually back to front, make sure everything's clear.
Well, that's a good part of the lesson is check your extremes, right? That makes a lot of sense. Well, I'm glad it wasn't more serious.
Yeah, I mean, it was a bit humiliating until I figured out what it was.
Were you able to keep using that wheel?
Yeah.
Okay. And the underwear? The underwear was okay?
Sheet metal was no match for it.
Yeah. I'm just imagining the sheet metal that was on the Micromaster. You could have built a bridge out of that stuff.
Oh, yeah. Not this stuff.
Well, guys, we did it. We went comfortably over time, which is fine. Last call for questions from the audience. Otherwise, we're going to wrap this up so we can all go outside and stare at the sun. Anybody have any questions? And Mr. Blodgett reminds me to remind you, don't forget to depress the vertically oriented opposable digit button. Do you know what that means? Yes, you do. Thumbs up. Give the video a thumbs up. Box the controls is what it's called when you do that with a plane. Very good, Indiana John. Nice use. He is correct, and we are in violent agreement because we're both pilots. When you take the stick in an airplane and you run it all the way around to its extremes, that's called boxing the controls, and that's what he is suggesting we do with the machine. That's kind of shockingly good idea for a machinist. That's pretty good. We will keep that in mind. All right. Well, gonna wait another 20 seconds here. Thanks, guys. Aaron, Adam, appreciate it. Next week, all our guests will have B's in their name. And I hope you'll come back and share some more wisdom with us.
I think you need a beard next time.
I think I'm the odd man out on that.
Yep.
Actually, last week I was getting close, but I gave up. All right. Thank you so much, everybody. Thanks for being here. Appreciate you. We'll see you guys next week. I don't know what we're going to do, but it'll be awesome. And we'll keep the grinder action up. Keep posting on Instagram and share. I will continue sharing my story of these here pins, which are getting more interestinger and interestinger, and that will also become a video, including all of the lessons. Adam Demuth, thank you very much. Aaron Walla, thank you very much. And we'll see you guys next week, next Sunday. Be awesome.
Happy Sunday.